Hi, everyone. Thanks for being here. So today we're going to talk about UX patterns for developers. Let us start by introducing ourselves. I'm Nicole, and I'm a UI UX designer, and I'm also a design teacher at Reusable, which is a coding bootcamp that teaches web development in 9 weeks.
And I'm Jad Joubran. I'm a full-stack teacher in Amsterdam, Brussels, Lisbon, and London.
So while coaching developers, we noticed that teaching developers about user experience and about design is really important. And instead of trying to find common solutions for common problems, why not tell them about some UX patterns to use in their everyday code? So we said, let's batch these predefined UX patterns and share them with you today in this presentation. So the term user experience has been getting a lot of attention lately. But not a lot of people know what it actually is and how crucial it is for their success. So UX is all around us. And to prove it, let's talk about it in a different perspective, in something that we use every day, the metro. How many of you have had a bad metro experience? So think about all the combinations of user experience combined together to give you this experience of the metro. It's a combination of process guidance, of typography, of choice of colors, of simplicity, use of contrast, familiarity, and a lot of other things that we use to make this user experience, and a lot of testing with users. So the point of the metro is to make you go where you want to go as soon as possible. And this is exactly what user experience in web design is all about. It's about a combination of methods and principles combined together to make the user happy. So it's about cognitive psychology, where we focus on the user's behaviors. It's about usability, where we focus on intuition and making things simple. It's about interaction design and motion and animation. It's about content strategy, where we focus on the voice of the product. It's about visual design, which is where we focus on the interface to make the product look trustworthy through design. It's about functionality, where we focus on features to solve problems. It's about data visualization, where we design complex information. And it's about information architecture, where we focus on the structure and functionality. So, as a definition, user experience design is a combination of methods with which you can solve design problems while focusing on the user. So, let's focus on two terms that are widely misused: user experience and user interface. It's really simple. They're really different. User experience is just what I shared with you earlier. But user interface is only the visual part. It's a part of the user experience process, but it's only the visual design, the interface. So why am I telling you this? Why am I sharing with you what user experience is and what are UX patterns? It's because user experience and development are like cousins. Both build with users, both test with users, and they have shared goals, so they solve problems. They have shared goals, but just different focus. And understanding how the customers use your product will make your products much more powerful. You'll be able to get inside the minds of the people that you built for. So what is a UX pattern exactly? There are reusable solutions to usability problems. So they're like universal design conventions. They're learned by users and are now familiar with them. So today we're going to share with you 7 patterns that we think are the most important things to consider whenever you're creating a digital product. I'm going to be talking about the design perspective of every pattern, and Jad will be tackling the technical part. So the first thing I want to tell you today is that don't make the user wait. Everyone nowadays hates to wait, and everyone is so impatient. So everyone wants their thing right now, or else they will get bored and just abandon your website. So always keep this in mind that people are impatient. 53% of mobile users abandon their sites that take longer than 3 seconds to load. Just 3 seconds. That's how impatient people are nowadays. So, to tackle this problem, let's take a look at 2 examples of loading a website. So the first one is a normal loading, where everything loads together at the same time. So we're used to this usually. We go into the website, wait for some seconds, depends how heavy the website is, and then boom, everything loads. Whereas a progressive loading is where things load one after the other. So component after component with a loading state. So this is a bit more satisfying, whereas the first example is a bit frustrating. So the second one reduces the perception of time and reduces the user's uncertainty. So let's see how we can do websites that load this way.
So we're going to start by identifying the 3 main events that happen whenever a user is loading our page. And the first one is the first paint. And this is a more technical preview of what Nicole showed us. Unoptimized rendering could show the user a white screen for around a few seconds, and then suddenly everything loads. Whereas optimized rendering is where we have everything loading progressively. So what I'm going to do now is I'm going to show you a snippet of an index.html, because this problem is quite frequent on the web. So I want to show you why it exists. So if we take a look at this example, we're loading just a CSS file at the beginning. We have a bunch of HTML, and loading a script at the end. And if we take this to the network tab with the 3G throttle connection, we can see that we're loading the index, the image, the JavaScript, and the CSS. The whole thing takes 5 seconds to load. And in this particular scenario, this is where the browser starts rendering on the screen. So I want to ask you a question. What is the browser waiting for before it can actually render? JavaScript, it's obvious. Anything else? The style sheet. So it's not very obvious, but the browser is also waiting for CSS. Because if the browser doesn't wait for CSS, it's going to show you some content, and then there will be a flash of unstyled content when the CSS is returned back to the page. So this is why, by default, we say that JavaScript and CSS are both blocking. They both block rendering. So we're going to explore one of the ways to unblock rendering, and let's start by seeing this for CSS. So we're going to unblock rendering for CSS by, first of all, inlining critical CSS. Has anyone done this before? So we inline critical CSS in the head, and then for the rest of the CSS, we dynamically inject it at the end. What do I mean by critical CSS? Well, just the basic amount of styles, or the basic styles that you would require as soon as possible, the things that you want to load or paint as soon as possible. So in this example, I'm just changing the background color of the body, removing the margin, and changing the background color of the header. And for JavaScript, unblocking JavaScript is much easier. You just add the async attribute on the script tag. Now this works if you have only one script tag. If you've got multiple ones and you need to guarantee execution order, you have to use the defer attribute, in case your scripts depend on each other. Now, after applying all of these optimizations, this is what we'll have. Inline styles, critical CSS. This shouldn't be too much CSS, just a few lines of CSS. The same HTML, async scripts, and inside those scripts, you'll be loading the other CSS asynchronously. And now let's take it to the test. Exact same thing. It still takes 5 seconds, but now we are able to render at 200 milliseconds. So let me show you side by side. By just working more with the browser, you're able to start rendering as soon as possible. And this is a pattern we see a lot in native apps. When you open Facebook on Android or on iOS, as soon as possible, you will see something that's painted. And this is why this is a pattern we should follow a lot on the web as well. And now let's take this concept a little further, and let's talk about the app shell. Has anyone done app shells before? So the app shell is just the minimal HTML, CSS, and possibly JavaScript that powers our user interface. So let's take a look at the same example and highlight the app shell. That's the app shell. It's like the container where the content that has loaded will go into it. So once again, this is the app shell, and once the content has loaded, it will go inside the application shell. So how can we achieve this? It's exactly the same thing we've done. I just want to show you that you can create an app shell with just like 30 or 20 lines of CSS. This is a floating action button, and that's the code for it. And we're just changing the background color, removing the margin, and giving a background color to the header as well. So it's just about the way you're designing it, about the way you're coding it as well. And after showing the app shell, we have another event, which is the first meaningful paint. That's because the app shell is not that meaningful to the user. It's not showing personalized content. It's just showing that the app is being responsive to our actions. So the first meaningful paint, we will see it here, is right now. So just when the content loads on the screen. And we have to make sure that the first meaningful paint does not take a long time after the app shell. And then the third step is when your app is ready for interaction. And this is the most important part, because a lot of times you've got the content in front of you, but you cannot interact with it. And the reason behind it? JavaScript. So this is a real trace that I took from nasa.gov on my MacBook Pro with only 5 times CPU throttling. The main thread was blocked for more than 8 seconds just parsing the vendor.javascript. So we don't want to block the main thread just because we want to parse big JavaScript files. So I'm going to give you some possible solutions in order to ship less JavaScript. And the first one is by using Source Map Explorer. Has anyone used it before? So Source Map Explorer is just a node module that explains more about the content inside your vendor.js. So this has helped many teams understand why they're shipping jQuery twice, or why they're shipping the whole Lodash library, whereas you only need one function from it. So by taking a closer look into your vendor.javascript, you'll be able to trim about 10, 20, or even more, 10% or 20% from your vendor.javascript. And you can also get into code splitting, especially if you're using Webpack. That way, you'll be able to push only the minimum amount of JavaScript for every single file. And the reason why this is a good thing is if you need to re-invalidate this home.javascript, you don't have to re-invalidate your whole app.javascript file, which is probably around 1 megabyte.
So Jad just told us how important it is to load things fast and progressively. But that is not enough. Showing good content at the first load is also important. So above the fold is a term borrowed from the newspaper industry, which refers to what is visible above the page before loading, before scrolling. So, of course, the exact location of the fold will differ for devices, but the concept still matters. So what we find at the top of the page will help us decide if we want to continue scrolling or abandon the page. So that's why building a story above the fold by creating a glimpse of interesting information will make us engage with the website and scroll to view more. So always prioritize the content that lead the user down the page. Now let's move on to the second pattern. We shouldn't forget that the web is fluid, which means it will differ on so many scenarios nowadays. It's not static. It will change, which means we have to consider different states of web design. According to Vince Spielman in his article, The 9 States of Design, he said, as we learn to craft systems rather than pages, we must invest effort into shaping these often missed states of design. So what does he mean by these missed states? Let's see. The first state of design is the nothing state. This is where before your item does something, before your product shows something. So maybe your component didn't do anything yet, or the first time the user sees it. This is the nothing state. The loading state is where we inform people that the system is loading, and we give them feedback to the visual. So this will also reduce the perception of time, and it will give the user something to look at while waiting. The third state is the none state. So this is where you have no data, no items, nothing to show. Instead of showing just a blank screen, why not use this opportunity to show the user something to make them engage? So the difference between this state and the nothing state that we saw on the first one is that the nothing state is before something happens, whereas this one can happen anytime as long as it's empty. So whenever I swipe everything as done in Google Inbox, I always feel like I accomplished something today when I see this empty state. The one state is when you have one item to show in a list, for example, or one item left. So we also have to consider this one state. What happens when you have one of something? The some state is basically the ideal state. This is where you have some items in a list, for example. The too many states is where you have too many things, and we have to think about what happens when this happens. So we add a pagination, we add a load more, we add automatic loading. So we have to think about that. Now, the incorrect state is where we have an error. So when we have an error, the user has to know that this error happened, why it happened, and what can they do about it. The correct state is the exact opposite. When something is correct, and sometimes we have to tell the user that it's correct. For example, when we enter an email address or a password. So this is where you tell the user that you're good to go. The done state is when we have a correct input and it's received by the app, and we have to tell the user that it's done, that they don't have to worry anymore. So always have a checklist of these 9 states of design whenever you're creating something, a digital product, in order to make it more consistent and to consider different states. Now, building trust and credibility is one of the most important things about user experience. Why do you think we use Airbnb and PayPal? Isn't it because we trust them and that we're familiar with them and we find comfort with them? So what makes an app trustworthy? First, having an interface that actually works and it is not broken is the most important thing to have. So here's a hierarchy of design needs that tells us how to make something trustworthy. So the first thing we have to consider is that the website should be functional and that it should meet some basic functional needs. The second thing is that it has to be reliable, so it has to provide consistent performance. It has to be reusable, easy to use without difficulty. Users should do more and better and quicker in our website. And it should be memorable. So everything we do on the website, we should remember it later on so we could come back to it. Reversibility is a design principle that says people should be able to recover from their mistake. This also reinforces trust with the product. Now, another way to earn trust with the user is to use good timing, especially for notifications and asking for permissions, for example. So we should tell them when they should care about the thing we're telling them about. And we shouldn't interrupt them and force them to pay attention on something they don't want to see right now. So here's an example of a bad timing of asking for permissions. Nothing can be more annoying than opening a website and immediately asking for your location, without relevant context, without anything. It confuses the user, and it will make them go away. Instead, if you ask politely and at the right time to ask for permissions in a respectful way, this will reinforce trust with the user. So for example, in Google Hangouts, after you go into Find Your Friends and tap Next, then they will ask you for access to your contacts. So this is a respectful way, it makes sense, and it's just respectful. So let's see why this bad timing issue happens to begin with.
So there must be a problem why this issue happens, especially on the web. And the root of this issue is actually the navigator.geolocation.getCurrentPosition. The problem with that endpoint, with that JavaScript API, is that there was no way for us developers to know if the user has given us permission or not. And the only way for us to figure it out was to call this method. And then this method would show the location permission again. So that's why a lot of websites had the website would like to get access to your location on the first screen, on the first loading screen. So how can you fix that? This is going to be fixed using the permission API. It still doesn't have full browser support. It's supported on Chrome, Firefox, Opera, and Chrome for Android. Hopefully coming soon in Edge and Safari, but not sure about it. And it just allows you to query for permissions. So you're basically asking the browser, do I have permission to use geolocation? And then the browser will tell you the state. And you can also listen for change events. So whenever you previously had access, but now you don't have to, or even the opposite way. So this should fix the problem that we've had on the web for permissions.
Using functional animation and installer animations that have a clear logical purpose will bring your user interface to life. So there are lots of types of transitions. For example, navigational transitions are movements between states from high-level view to a detailed view, for example. And Google uses this concept in their material design components. In Google Calendar, they use this navigational transition to navigate from an event to event details. So these kinds of transitions focus on the component that we navigated to. Also, gestural navigations allow us to use swipe gesture to navigate between different views. So here in Google Inbox, in their app, they use this gesture navigation to swipe and close an open email message. But let's see what makes a good transition. We now know that transitions smoothly transport users between navigational contexts. But what really makes them good transitions? So first, a transition has to be responsive. And by responsive, I don't mean responsive with the device, but responsive with the tap of the user. Now here, it's not showing the ripple effect it should be showing, but maybe because of the high contrast. But when the user taps on somewhere or clicks somewhere, there should be a feedback mechanism here, that the user clicked here. Transition also should be natural. Every movement we do should be inspired by forces in the real world. This is what makes it a good transition. A transition also has to be quick. So the movement should be fast enough that it doesn't cause waiting for it, like this one. A transition also has to be clear. So always keep animation clear, and the duration of it is under 300 milliseconds. So transitions will make your app look smooth and delightful to use. But there are scenarios where sometimes transitions lag, even though we worked really hard on them to make them smooth. So if a transition lags, it will hurt our user experience instead of making it better. So let's see how we can make transitions that don't lag.
So I'm a big fan of material design, and the first time I was looking to these animations, I thought there must be very easy, right? I mean, he's just animating the width, animating the height. I'll use CSS3 and it should be super fast, right? But unfortunately, that's not the answer. So I want to tell you quickly what happens from DOM to pixels on the screen. So what is the pipeline that the browsers follow in order to draw animations on the screen? And after understanding this, you'll be able to know why sometimes transitions can hurt the user experience if they were lagging, and how to make them even faster. So this is the pipeline that most browsers follow. The first step, there are 5 steps. And the first step is when we trigger the animation. So we call it JavaScript, but you can trigger it either using JavaScript or CSS. And then the next step is when the browser recalculates the styles. So this is when the browser figures out, okay, this class applies to this element, and these properties apply to this element. And then afterwards, the browser has to calculate the layout. And the layout is just the geometry of the page. So everything that used to have percentages in it will become fixed width, will be calculated into fixed pixels. So that's an example of the geometry of Airbnb landing page. So everything will have like 200 pixels times 300 pixels, etc. And then after calculating the geometry, the browser has to paint those pixels into different layers, because the navbar is probably on a layer, the landing page is probably on another layer. And finally, the compositor will merge all of these into the screen and draw it onto the screen. So those are the 5 steps. And now what I'm going to do is I'm going to map some CSS properties to one of the last 3 sections of the pipeline. And we can actually map width, height, margin, top, left to the layout phase. Because if you change the width, the browser has to redo layout. And for the paint, we can map background image, background color, box shadow, and border radius. And finally, the compositor can take care of properties such as transform and opacity. So armed with this knowledge, I'm going to show you 3 animation scenarios, and we're going to see how the browser is able to animate them on every single frame. The first scenario is what happens if we animate by changing the width, or left, or top, or margin. So we change the width, so the browser has to recalculate the layout. We have a new layout, so the browser has to do paint again, and the compositor has to merge everything back onto the screen again. So this is going to happen on every single frame. So imagine how expensive this is. And we only have a limited, very limited amount of time to finish this. So that's why animations with width will actually struggle. And the second scenario, what happens if we change the background color? Well, there's no way that changing the background color can affect the geometry of the page. So the browser is going to skip the layout, and it's going to do paint and then compositing. You can probably see where I'm going with this. What happens if we animate using transform or opacity? Well, the browser is going to skip layout and paint and immediately jump to the compositor. So that's why this is the most desirable for high pressure points. And when I say high pressure points, I'm not talking about small transitions, like if you have a background color and you want to change, if you have a button and you want to change the background color. That's fine if you change the background color. But once you're doing full page transitions or dialogue transitions, you have to be careful. And you have to work with the browser more. And that's why we can conclude that there are 4 properties, there are 4 things that the browser can animate cheaply. So you can move an element using transform, translate. You can make it bigger or smaller using the scale. And you can rotate it, and you can even change the opacity. That's because the compositor can take care of these in most scenarios and make it fast. So what does it mean for us as developers? It means that we have to always think, whenever we have a high pressure point, in terms of these 4 properties. So never think about animating using width or height. Always see if you can do it using scale. Never try to move the element using top and left. Try to do it using translate. So I've prepared a small demo here, and I'll show you how the browser, why it's actually important to do this. So this demo was actually prepared by Paul Irish from the Chrome team. And I have a Mac. Oh, okay. I will have to. Okay. So you can see here, I have a MacBook, and that is animating. That's okay. And the way it's animating is by using the left property. And this is a heavy MacBook. What I mean by heavy is that there are a lot of box shadows. And that's because we're putting the browser to the test. So what I'm going to do now is I'm going to go ahead and add a few MacBooks. But before doing that, actually, I will open the inspector and go to timeline, and enable CPU throttling, because I want to simulate mobile performance. So I'm going to emulate 5 times CPU throttling, and I'm going to add a few MacBooks. And you can see after adding a few MacBooks, the animation is not smooth anymore. That's because the browser is probably doing a lot of work. Whereas if I go clear this and apply the better way of animating this by using transform, translate X of 500 pixels, even with CPU throttling, we still have CPU throttling, you can see that I can add up to 100 or even more MacBooks, and the performance will still be really fast. So I still want to show you a visualization behind this. I want to show you how much work the browser is doing. So I will revert once again to the slow animation and open DevTools, press Escape, click on the overflow menu and go to rendering. And I'm going to enable paint flashing. So the browser is going to paint a green square whenever it's doing paint. So when is the browser doing paint? On every single frame. And if I add another MacBook, well, the browser is repainting every MacBook on every single frame. So now if I go and revert to the fast animation, we still have paint flashing, and it seems the browser only has to paint the MacBook once it brings it into the screen. And then this is the compositor that's animating everything. So this is how you can visualize sometimes that the browser is doing way more work than it should be doing. So that's why you are able to achieve fast transitions in this scenario. All right.
We always have to consider that the user might lose connectivity someday when they're using your website. So we don't want to break their user experience when they're using our app and something happens. And not only if they're disconnected from the internet, but also if the internet is slow. So there's always this in-between online and offline. It happens a lot. So let's see these two examples. Imagine you were sending a text, and you'll go into the metro, and the internet is gone. On WhatsApp on the iPhone, you can't really continue texting anymore. You have to just stop, because the internet is gone. So this is what I mean by breaking the experience. While on the Android, you can just continue texting, and it will be received when the internet is back on. So users shouldn't feel offline when they're using your website. They should be feeling like they're using, like nothing happened, and when the internet is back on, it will work again. So let's see how we can do websites that work offline.
The key point of making a website work offline is by adding a service worker. And the service worker is just a script that is run by the browser in the background and independently from your web page. And this actually opens up a lot of possibilities to do push notifications, work offline, intercepting requests, and even background sync. But we're going to follow two strategies here in order to be able to serve an offline version to our users. The first strategy is by pre-caching our main content, and then the other one is dynamic caching. So let's start by pre-caching. So what we want to pre-cache is actually the app shell that we defined earlier in the first UX pattern. So we have the app shell, and we want to pre-cache it because we want to serve this independently from the network condition. If the network is slow, if we are offline, we want to always ship the app shell. And this is what happens in native apps. If you open the Facebook app, even when you're offline, you will get the whole app shell first, and then you'll get a message that you are offline. And this is a comparison before and after adding a service worker. And these are the main files that we require for the app shell, for example, the index.html, the logo, and the speed dial. They are being served from the network, whereas after installing a service worker, they are being installed reliably from a service worker. And what this means is that we are able to show a custom offline experience. Now, I know this is not super nice, but this is only the first step of it. Instead of showing the offline dinosaur, we are able to show our own custom offline experience. So now let's take it a step further and see if we can make our app work offline. And this is where dynamic caching comes in place. And for dynamic caching to work, we have to use one of those three strategies: cache first, network first, or fastest. So I'm going to show you how they work. This is cache first. So this is a page, and it's being intercepted by a service worker, and the green dot is a network request. So let's see how it works. A network request goes out of the page, it gets intercepted by a service worker, and then goes to the cache, and then the cache will return the data back to the page. So this is nice if you know you've got some data on the cache and you want to read it independently from network condition. Now, network first is when you have, once again, a network request coming out of the page, and then the service worker will go to the network, but for some reason the network's going to fail. And this happens a lot. It could happen if you go offline. It could happen if you have unreliable internet connection. So what happens now is that the request is going to backtrack to the service worker and then get forwarded to the cache, get the data that you want, and then forward back to the page. So what this means is we try to get the content, the most recent content from the network. But in case it fails, we don't just fail. We just return some stale content from the cache. And the last one, which is fastest, or stale while revalidate, is slightly more complicated but more interesting. We have a network request that gets intercepted by a service worker, which then spawns two identical requests, one going to the network and one going to the cache. Now, obviously, the cache is going to return much faster than the network, but then what happens is that the response from the network is going to update the cache for the next time we use it. So this allows you to use stale content from the cache immediately, while always updating the content of the cache whenever we get the response back from the network. So you could use a mix of these strategies depending on what content you're loading. So if you're loading critical content, you'd use network first. If you don't care about serving stale content, you would use this one. And if you want to get a little bit technical, this is a configuration file for SW precache, which allows you to do everything I told you about so far. This is how you cache the app shell. You define which files you want to precache, which files you want to be part of the app shell. And this is how you specify This is how you specify dynamic caching, by specifying a URL pattern. So whenever I go and get an API, from the API, the list of countries, this is a regular expression, then I will use the cache first handler.
How many of you have had a bad mobile experience? I know. We always think that the desktop or laptop is the majority of the users, but it's not. That's because we use the laptop all the time. But actually, if you're not making your mobile visitors happy, you're disappointing the majority of the people who are using your website. Mobile users are growing and growing and growing. And according to research by Morgan Stanley, the number of global users of mobile are growing and growing every year. And it surpassed the number of desktop users. And that's in 2015, so it's still growing even more. And surprisingly, 7 in 10 users prefer mobile website over mobile apps across devices. So that's why we have to invest time to work on web apps or websites that work on mobile, to make them smooth, fast, and as native as possible.
So what I'm going to talk about right now has a prerequisite of making your app work offline. And assuming we've made our app work offline, we can make it as a progressive web app to benefit of native functionalities, or at least native behavior. So we have to use the web app manifest, and the web app manifest is a JSON file that tells the browser more about the content of the website. So this is an example of a manifest file for Foursquare, for example. You specify like short name, theme color, background color, a lot of options. And you can see on the right how it affects the workflow of adding to home screen. So for example, the user has added it to his home screen. Now when you click on it, you will get a splash screen. And you can see that this is Chrome now, or this is the browser that's opening our progressive web app, but the user doesn't know this because it looks like a progressive web app just by defining this manifest file. And the main point here is the display standalone, which hides all of the stuff that are related to the browser. So once you've made your app work offline, do take the extra step and make it as a progressive web app by adding the web app manifest. And once you've done that, the browser will actually go ahead and ask your users, we notice you're using this app, would you like to add it to your home screen? Instead of the user going to the overflow menu and adding to home screen. So this has obviously positive effects on the user experience, and especially that your users will have you on their icon, on their desktop. Now, the browser doesn't show this for all the websites, obviously. There must be some criteria. First of all, you need to have a web app manifest, a valid web app manifest. You need to have a registered service worker, and you need to be running on HTTPS, of course. Actually, all the service worker functionality only work on HTTPS. And the last criteria is the browser will wait for you to visit the website once, then at least 5 minutes, and then the next time you go to this website, it will ask you if we want to add it to the home screen. While this is nice for real users, it's quite annoying for us developers to test. You'll have to push code, go to the website, get coffee, etc. So actually, there's a Chrome flag. You can go to the Chrome flags and bypass banner engagement checks. So that way, the first time you go into Progressive Web App, the browser will ask you, and you will see if it works or not. So now we've got an icon on the home screen, but you actually have to meet user expectations, because you should remember that our users don't even know that the term PWA or Progressive Web App exists. They don't know that this is the browser hiding and showing you content in a web browser. If they have an icon on the screen, then they think this is a native app, and which means it should behave like a native app. So that's why there's the awesome Chrome plugin and even Node module called Lighthouse, which allows you to understand where you're doing good in terms of UX and where you could have some improvements. So for example, it shows you the first meaningful paint. It makes sure you have a registered service worker. It has a lot of performance metrics. So you can use this as a Chrome plugin or even as a Node module as part of your continuous integration. Do check it out. It's awesome. And my personal tip is to always continuously test on real mobile devices. So make this as part of your developer routine. So we always test on Chrome DevTools, on a MacBook Pro or on a Lenovo, but that's not going to simulate what happens on mobile. And you can also use throttling features in Chrome. Also do use them, but make sure that they do not replace real testing on real devices. I personally use a lot the CPU throttling and network throttling as well.
Now, enough technicalities for today. Let's move on to something different. How to use persuasion to make the users engage more in our website. So, first off, curiosity. We crave more when teased with interesting information. That's why revealing a bit of information of something will make the user engage more. It will tease them into taking action to reveal more. So this will keep the users hanging on. For example, in UX Spin, they play on curiosity with a dimmed video in the background of their app actually working. So this really makes us want to click on that input, enter our email in order to try it on, because we can see how it functions in the background. Scarcity is when something has a limit. And when something is being scarce, we perceive it as more desirable and more valuable. For example, in Cheapo Air, they use scarcity to engage users into booking these last 2 tickets. So they say, there are only 2 tickets left at this price, and if you don't book it now, your flight is gone. So this limited amount offers to push users to make a decision now rather than later. Reward is when we want encouragement and a sense of reward. And we saw something similar to that earlier. So building this sense of reward into the user experience will make them engage more and come back to your website. For example, in Duolingo, you receive points as a user. You receive points and badges as you complete different courses. So when you see this percentage, 39%, this will hook the users and will make them come back to finish them. We always consider the actions of others in new and unfamiliar situations. So that's why we always show that others are using our product and that they like it. And the perfect example of this is how we add testimonials on our website or use cases. So we assure visitors that the product is well respected and frequently used by their similar others. So let's recap everything. We now know that to make our website have a better user experience, we shouldn't make our users wait. We should also consider the different states of web design. We should earn the user's trust, enhance the user experience with smooth transitions, make the website work offline, optimize the website for mobile, and play on persuasion patterns. So by doing all these smart patterns, you will engage the users, make them come back, and talk about your product. Always remember that these UX patterns are a starting point, not an end. So you can always put your unique twist on any UX pattern once you know what makes it work. There are many other UX patterns that you can find online. If you're interested in knowing more about these, you can find this list of resources that we used to create this presentation. I hope you enjoyed the talk, and we're happy to answer your questions.